Good afternoon. My name is Walker Daniel. Today I'll be presenting Lab 3 circuits. The purpose of this lab was to predict the circuit behavior and then create a circuit to test these predictions. Additionally, we had to compute unknowns. The system was the circuit and the surrounding was everything else. Here are two fundamental concepts that were very useful for this lab. First is the loop rule. In any closed loop or circuit, the total voltage around the loop is zero. This means that the energy supplied is completely used up by the components in the circuit. And the second useful component is Ohm's law. A current through a conductor at 2 points is directly proportional to the voltage across 2 points, and that is expressed with the formula V equals IR. This is a little bit about the experiment. First, use clip lead leads to connect two resistors in series with two batteries and two ammeters. Make sure everything um, is in order to prevent damage of equipment. Then record the ammeter readings from uh, I2 to I1 to I2, and then record the voltmeters. Next, uh, measure and sum the potential differences. Then graph and connect the resistors and capacitors and note the difference. So here are some images of the experiment. So the first one is the simple circuit, which is sort of the first part. The second part is the RC circuit. Here's some of our data. Um, um, in the simple circuit, initial ammeter readings were 19.1 MA, voltmeter readings were positive 3.3 volts. Potential differences A to B, as you can see from this graph, A to B equals 2.98, then C to D equals negative 9 point or 1.96, E to F is negative 1.02, and the sum is zero. And then for the RC circuit part, we can see that the charge time for the lights was 4.33 seconds and the discharge time was 4.7 seconds. And here's a little graph, and you can see it's downward sloping. There were some possible errors. Of course, we're not perfect. So there were some human errors possibly. Also faulty reading with the equipment. A lot of the equipment was broken, so it was hard to know what was true data. And also incorrect setup could have caused some issues. Finally, the discussion. Our first question, or our first and only question is, what if your charge capacitors with no resistors in the circuit? How quickly would the ideal model predict the capacitor to reach full charge? And with no resistors, we can predict that it would charge much faster when the capacitor was directly connected to the battery. It charged almost instantly, and so did voltage. And that is all I have. Thank you so much.